Hello everyone, this is Yatisha Rajanala and I'm going to present my Teach 1 topic, Logistic Regression using the Blackboard Logistic Regression Week 1 Question 3 datasets. So what is logistic regression? It is a statistical method used for binary classification, which means it is well suited for predicting the probability of an observation belonging to one of two classes and is widely used in various fields, including machine learning, statistics, and medical research. In our case, we will be dealing with two datasets to predict, analyze, and model whether the PCR test results of COVID-19 are positive or negative using the variables of age, gender, symptoms, and at-home test results for COVID-19. So the first dataset is the data frame, which consists of various independent variables which can determine the dependent variable of PCR test results. The next dataset is the lookup table, which has the data regarding the combinational symptoms and the number of patients having each paired set of symptoms. So now we will get the solution of our question using the R code. So first of all, we need to load the libraries. And the libraries which we will be using today are readr to read the CSV files, tidyverse for data manipulation, caret for the creation of dummy variables, glimnet for lasso or least absolute shrinkage and selection operator regression, and PROC, which is used to calculate area under curve for the ROC or receiver operating characteristic metrics. So we will run these libraries and we will load the data. The data which we will be dealing with today, this is the question which we are going to explain through this Teach 1. And the data is, this is the data, and this is the data dictionary, which has the column names and which corresponds to the data, as well as the lookup table. So, and this is the lookup table, the number of times two symptoms occur together for the same person. So these two are the data sets which we need to download. And after downloading, we will load the data. And next, we will view the data columns for the data frame. So as you can see, the names are not comprehensible and we have to rename the variables so that we have the matching symptom names in both the tables of the original data set as well as the lookup table. So next we are going to rename them. And that is the end of part 1, that is loading of data. Next we move to data cleaning. So first we will start with cleaning the lookup table. So as you can see here, the lookup table consists of combinational symptoms or paired symptoms. So this is the column names for the different symptoms. And as you can see, this is where, like, for example, if we have fatigue and loss of sense. So 14 patients have reported both these symptoms together. And similarly, confusion and difficulty in breathing, we have 5 patients who have reported them. So now for making it easier for our analysis, we are going to calculate the total of row sums and arrange them in the descending order to get the most common symptom pair. And as there is no first column, it auto codes as 1. So we will run the code. And so we are sorting them in the descending order, and we are going to extract the ordered list, and we are going to print it. So we get 29 order of symptoms. And next, we are going to move on to the data cleaning part for the data frame. So here we are going to create a duplicate data set so that we can extract only the necessary variables from the vast data frame. Now, first, we are going to drop the rows with missing PCR tests, and further on, we are going to drop the rows with missing predictor values. And then we are going to summarize to check if there are any other necessary changes that have to be made. So as you can see the summary table, there are missing values. So we have to fill them up. So except for age, for the rest of these symptoms and gender and everything, we can use the most frequent value, that is the mode. So we are going to run this code. And for age, we will be calculating the mean. And for gender also, we are going to change the gender as 1 for female and 0 for males so that it becomes a binary code and makes it easier for our regression analysis. Also, a dummy data set is created for the at-home positive test results column, which is a binary variable having positive or negative test results. Here, I would like to add that many machine learning algorithms, including regression models, require numerical input. So dummy variables are used to represent these categorical variables with 2 or more categories as zeros and ones. In this case, for our at-home positive, it's a binary variable. And so creating dummy variables allows incorporating it into models that expect numerical inputs. So we are going to run this code. And we have changed it to zeros and ones. Now we are going to summarize the data to check if any other data cleaning processes are needed, and it looks good. And now we can move on to the regression analysis to answer the given questions. So the first question is that build a model that includes only home test results as an independent variable and report the percentage of variation explained. So first of all, we are going to build a regression model, logistic regression model, which has only the home test results as the independent variables. We are going to summarize the model, and there have been 15 iterations done. Now we are going to extract the pseudo R-squared value, which is 0.2079. So based on this, we can infer that approximately 20.8% of variability was explained by this model, with the home test results as the independent variable and the PCR positive as the dependent variable. Now moving to the next question. Build a model that includes age, gender, interaction of age and gender, and home test results as independent variables. Report the percentage of variation explained. So here for this model, we will consider age, gender, interaction between age and gender, and home test results as independent variables with PCR positive as the dependent one. So we are going to build the regression model, then summarize it. So there have been 15 iterations done. And here we are going to calculate the McFadden's pseudo R-squared value, which is 0.2493. So by this, we can infer that about 24.93% of the variability in the log odds of getting a positive test result was explained by the given independent variables. And now moving to the next question. Build a model that includes age, gender, interaction of age and gender, home test results, and symptoms as independent variables. So with these as the independent variables and PCR positive as the dependent variable, we are going to build a logistic regression model again. And we will be including all the symptoms that we have listed out in the beginning of data cleaning. And we will run this code. Summarize the model 3. There have been 17 iterations done. And using this data, we are now going to extract the R-squared value, which is 0.5739. So approximately 57.39% of the variation was explained using this model, the third model. Now moving to the fourth question. Build a model that includes age, gender, interaction of age and gender, symptoms, home test, and pairs of symptoms as independent variables. Report the percentage of variation explained. So here, first of all, for creating pairs of symptoms, we need to note down the symptom variables and then create the interaction pairs for all of the symptoms. So we will run these codes. And we also have to remove pre-existing interaction columns from the data frame. So if there are any pre-existing interactions as from the lookup table, then we have to remove that and then bind them together, make a sum, calculate the sum, and we then build logistic regression model using the GLM function. And then we summarize the logistic model. So as you can see, there have been 20 iterations done. So here we have fever, muscle aches, fever, chest pain, and muscle aches, runny nose. So these are all the combinational symptoms and the different readings that we have got for each pair of symptoms. Then we extract the deviance values from the logistic model, and we further calculate the McFadden's R-squared value using those deviance values. So we get 0.7623. So this suggests that 76.23% of a variation was explained using the last model, that is the fourth model. And also, next, moving to the next question, question 5. What is the most accurate way of diagnosing COVID-19 at home prior to triage to clinics is, the thing is that this code tries to explore the different symptoms using the independent variables as age, gender, and home test results. These are quite good predictors for a positive COVID-19 PCR test result, but there are also other factors which can be included as well. So, however, this potentially helps in predicting the likelihood of a person being positive, and this is an accurate way of diagnosing COVID-19. So the next question is, can a clinician learn to make these diagnoses, or a number of adjustments that are needed are beyond human capabilities? So first of all, these models are very complex and they can be done by data analysts or statisticians. However, a clinician's job would be to use these models and integrate the results into clinical systems to help decision-making process much easier, so that the patient gets better diagnosis, better treatments, and better outcomes. So it is not just that he has to rely completely on these models for clinical judgment. He can just make better clinical judgments with the use of these models. So a balanced approach is essential for any clinician. So this is the end of my Teach One video. I hope my video was helpful to you. Thank you so much for your time.